Good morning. I'll try to use this mobile microphone because I like to walk. And please feel free to ask questions during the talk. It's supposed to be also interactive if you would like to. And Stanislav has been kind enough to agree that he will watch for my time. So he'll be signaling if I'm getting longer than that. So my name is Jan Kleindienst. I am a long time an IBMer that 3 years ago with a colleague started a company called Mama AI. And in our company, what we do is we build artificial intelligence. So our IBM history goes back to 90s when we started to work first on the systems of speech recognition and synthesis. And then over the years, we have been the founding partner of artificial intelligence created by IBM called IBM Watson. So we've led the team here in Europe that worked on IBM Watson technologies. And in 2021, we decided to start our own company that we position as a European company that builds products and services using applied artificial intelligence. There are 6 co-founders. There's plenty of work, so we do have things to do in the Mama AI. And you can watch some things we do on the stand that is in the aisle. I don't want to go into details, but basically built several kinds of artificial intelligence, starting from communication voice bots and chatbots to intuitive search engines, to personalized AI and things related to virtual reality. We will talk today about reasoning and generative AI related to large language models, and we will not talk about the blockchain. So the first question people ask is, AI, is it just another hype or is it real? All of you in the room already have some experience with AI. I'm sure at least we are being bombarded from the news how enlightening or endangering AI is overall. So everyone has its own notion. The truth is that AI in the green box is the next era. And that era is called human cyber-physical systems, where something which is the information processing engine in our human head blends together with the information processing engine in the head of a computer. And one thing to notice is that if you look at the previous eras, starting from the steam engines to mass production, to computers, to internet, then there's been typically spans that covered several generations. But as we're progressing towards the green box, notice how things are getting faster, and we feel it in our lives. So the last from internet to AI, it's been only 10 years. If you make the progression, it's probably something that is coming in another 10 years. So in the span of our lives, which are even getting longer, we probably be subject to several of these waves of evolution and revolution. It's good to keep that in mind. Now, what are the consequences of that? The world is changing, and we experience it. And for the businesses that we run, and for the businesses we supply with our products, it's important to realize that let's not take the current business model as the one that is granted forever and ever. On the other hand, be able to constantly challenge the way we do things, because that's the only thing to survive in this fast-changing world. And the last bullet is, if you don't do that, then maybe you are big enough to survive that. Or maybe you find your niche to live in that space. But if you don't do either of those two things, you probably need to start looking for something else in terms of companies. So this is very interesting times where the playing cards are shuffled on the table, and many companies will be starting again because of these new things that are on the table. And it's good that we talk about it a little bit. It's not always easy when the new era comes. Right? this is probably not widely known, but when the calculators have been introduced, and Texas Instruments has been one of those big providers of calculators, then the math teachers started to protest in 1966 on Texas streets, don't use the calculators yet, let the children to start with basics and then only use the calculators, which had a snippet of truth, obviously. But yeah, that we will see the waves and counterwaves in this movement, in this revolution. Now, if you look at the positive side of things, what AI can bring you, there are basically two things on the spectrum. One is help you handle the routine work, things that people make mistake, they don't want to do it, it's boring, it's taking energy. Handle routine work, contact centers, for example. 80% of the contact centers work can be done by computers with a reasonable mean opinion score of people accepting that. So that's a routine side of things. And then on the other side of the spectrum is you are an expert, and AI can enhance your skills to be even better expert, to be able to read more articles that you usually read, to be able to understand more that you usually understand. It's augmentation. So it brings better insights and optimization in decision processes. So on both of these sides of the spectrum, AI can help, and some of the demonstrations you will see in the corridors. Another important thing to realize is there's this saying that AI is what IT used to be 30 years ago. If you think about 30, 40 years ago, none of your companies had any IT department. IT was probably something that was run at the universities, which been experimenting with some of the internet connections and so on. Now everyone has IT department. And everyone pretty much knows, it's a popular culture, everyone knows what memory is in a computer, that computer has a disk space, there's some network, some connectivity, there's some hardware, some software, maybe the software has bugs, there are viruses. We all know that. Even our grandmas are knowing that because they're buying computers for the kids. Right? So these are pretty much something that is part of the culture. Not everything, but definitely the concept of a computer connected to the internet. There's some graphics. There is something that's going on. In AI world, we need to learn these concepts to put them into our common thinking and jargon. And these concepts are concept of data. Why do we need data when we're training AI? Concept of the model. What is the model? What it's doing? Why is it needed? What is machine learning versus deep learning? What are the model parameters? There is a concept of training and testing when we work with AI, and things like bias, error rate, and some typical issues associated with AI, which is hallucination and overtraining. Right? None of these concepts you probably, well, some of these concepts you will hear today in this little talk. And the truth is that soon enough, many of those IT departments will be slowly expanded to AI departments as well. Maybe some new AI departments will be created at the positions of line of businesses, because every line of business may need some specific needs for the AI. We'll see how it gets played out. There are very interesting signals coming from the industry on that. So, motivation, why we have AI, why is it here? There's one thing. I've been growing up as a programmer. My specialization is mathematics and programming. So when we've been asked to, at my study times, been asked to describe what that lady is doing in the various positions on this picture, we would probably start with writing a code that says, in this case, if the lady is walking, we would say if the speed is less than 4 miles per hour, then she's walking. If she's running and we want to distinguish running from walking, then the statement would be something like less than 4, walking, otherwise running. If you add biking into the equation, then the if-then-else statement gets a little bit richer. But once you start modeling something more complex, now you may run out of your programming skills. Like the human head has certain limitations. we don't probably are able to store the entire rules that needs to be written to model the behavior of such a person if the number of states is much larger than that on the picture. Probably 100 rules would be enough to fit in one head. And then we start making mistakes because you get the crosstalk between various states. Right? So we run into the wall with that approach. We still use programming. I mean, it's not that we don't, but with the promise of machine learning, here is another approach how you can solve these things. And that approach is, and that leads us to data and model, the approach is that you encode that physical object, being a human, be it a human being or something else, as a zeros and ones, as some kind of vector. You can call it embedding, you can call it some representation. It's something that describes that person. Could be that whenever this is a picture, 2D picture, whenever there is something from her body on the picture, it's 1, whenever there is nothing, it's 0, or it could be just individual body parts are encoded somehow in this code. But the point is, now you have a representation of this action in a digital form, and you say, this representation to me represents walking. This representation to me represents running. That is biking, and if I keep adding more and more, then I just keep adding more and more labels, or more and more examples. I may have more examples of how the lady is walking, I may have more examples of how the lady is running, and so on. So that's the promise of the machine learning. That's actually what's happening under the hood in many cases. We represent things as representations, and then we have techniques to learn these tasks. So how is that realized conceptually? So for the first case, when I'm doing the programming, I'm the person who needs to write the program. My expertise from my head gets into the program, and then the program is doing the task. It's getting the data, the position, the speed of the lady, and then deciding on the rules of the program. I get the result, the lady is walking or biking. That's the conventional programming. In the machine learning concept, I let the machine use the data, so the data, which would be the zeros and ones, and the results, which would be that those zeros and ones represent walking, or those zeros and ones represent running, and then I let the machine learning algorithms to write the program. So the machine writes the program, and then I use the program written by the machine to make the decisions. Right? So that is the fundamental change in the way how we scale ability to create programs, not by humans, but by machines. Now, what is the relationship between the three terms that are often used? Artificial intelligence, machine learning, and deep learning. AI is something that is prescribed as a program that can sense, reason, act, and adapt. So it's something that represents some faculties and capabilities of human mind to some extent. And to be able to do that, we need machine learning algorithms like those I described on the previous slide. And then since we do like to do reverse engineering, we have looked at how the human brain is dealing with such concepts. And we figured that human brain represented by neural networks, what if we mimic those neural networks on a software in silicon and create machines based on that? And those machines, those large neural networks are called deep learning. And why it's deep? Because there's many layers of those neurons that are used to represent the phenomena we need to model. So every time you hear deep learning, it's a subset of machine learning, and machine learning is an essential part for doing artificial intelligence. So now, once we copied that concept from the human head, we put it in the silico, then you get similar things that you've probably seen on many pictures, which is the neural network is represented as a beast that has input layer, output layer, and several hidden layers. We don't need to go that deep today, but basically imagine that girl and you're trying to determine if she's running or walking. So here on the output, this thing would have something close to 1 if she's walking. This would have something close to 1 if she's running. if she's biking or she's golfing. If you need to add additional states, then we'll just put more neurons at the end. And the zeros and ones on the input would be fed from this direction. So he would be 0, he would be 1 for one particular case, or vice versa. And then you would tell the network, learn this mapping of 0 and 1s on the input to the actual output. So this is the mechanism we train the neural networks in a way how the human had to train, even though this is happening much faster, as you will see on some other slides. So that's the basic concept. And if you go into what's inside this blue box, it's a pretty simple thing. It is just a combination of weights on the input. Right? These synapses that we have in a human head, which connect one neuron to another, and these synapses are represented by weights. So one synapse, another synapse, another synapse. Then we just summarize the results, run it through some kind of non-linearity, and then we fire the information out of the neuron to another layer. And that information could be inhibited, or could be accentuated, or could be the same, depending on what's the neuron learn in the learning process. And the typical way it behaves is, you say, this is on the input, this is supposed to be this is on the input, this is supposed to be on the output. If it's not, then find the differences, why it's not, and then propagate the differences between the truth and what you actually decode back to the neural network and make the neural network learn. And the algorithms are determined in such a way that they converge in many cases. So we're able to learn on that in this kind of networks. Now, what do you think is the key parameter in terms of these networks? One of them is obviously the performance, how well they can perform on the task, but that performance is oftentimes correlated to the size of the network. Because the bigger network is, then the more things can do. So the size of the network, those large language models you probably heard about, there is a huge space. So does anyone know what's the size of the GPT-4 in terms of number of neurons, these artificial neurons, plus the number of synapses from each neuron, roughly? Well, yeah. Well, I'll show it on the next slide. Actually, it's huge. So let's take a look at the human brain first. So the human. Oh, I see you don't see the bottom line. Doesn't mind. So the human brain has about 86 billion neurons in our heads, right? We have 86 billion neurons, so 86 blue circles in our head. And then each of those 86 billion neurons is connected on average with 7,000 those black lines connected to the other neurons. So if you sum it up, it's about half a trillion or half a quadrillion, 500 trillion synapses in our head. Now, if you look at the large language models, GPT started with this 175 billion parameters compared to trillion parameters, but now with GPT-4, it's already in the order of trillions. So still, we have like 200 more to go if we want to match the size of the human brain, but that's not the point. But at least you see how things are getting closer. Again, the size doesn't mean that performance will be superb. It also depends on the data you train it with. As you have a genius, and if you that has an excellent brain in his head, but if you feed him wrong data, he gives you wrong answers. So data are also an important piece in this equation. But just to get the orders. Now a little bit about the history of AI. We don't go into the details of this chart, but AI started right after the end of the war, and with the Iron Curtain being in place, the world has been, one side of the world has been very much interested in what's happening behind the curtain, and can we have some automated algorithms to be able to understand speech, to be able to translate from one speech to another, to be able to extract meanings. So in 1955, the term artificial intelligence has been coined by John McCarthy, which he described it as a science and engineering of making intelligent machines. And then it picked up the story of its own. It's been all over the news, in media. Everybody was projecting to it its own feelings and visions, and it created a lot of hypes. A lot of funding, and a lot of expectations. It turned out that we didn't deliver on those expectations. So in 70s, the AI has been sort of a dead horse. Funding stopped flowing into the AI, and we experienced something called AI winter. But with three things happening in 90s, and at the end of the century, there were three major things. One was the data has been much more available because many companies started to digitize data. So data was one of the first ingredient into what became an AI summer. Another thing was computers has been better and better. So the GPUs that we needed to train the neural networks have been readily available, and it's been useful for the training. And the third thing is the theory behind the neural networks and how to efficiently train the neural networks have been in place by George Hinton and other colleagues that started to actively work in this area again. And that this perfect storm of three things actually kick-started the AI summer, and now that led to where we are today. And in the process, some of you already have some Roomba robots running in your homes. Some of you probably use Siri, Alexa, or even Watson, and so on. So that was the conception of AI, the AI 2.0, I would say, after the summer. And in terms of the landmarks, 1997, the machine were able to beat human chess players. Kasparov was the top chess player. The machine beat the Kasparov. So that was a huge milestone in terms of now we realize machine can actually be better than we are at certain purely human things. And that trend continued with AlphaGo that has much more states than chess. Again, Google has created a machine that has been able to beat the master in the AlphaGo, and the march in the gaming industry continued. Then in 2018, the OpenAI team put together a team of 5 robots playing together to beat the team of 5 humans in this famous game called Dota 2. Bill Gates, a big fan of AI, commented that that's a big deal because now the machines can collaborate together in this game and elsewhere to solve complex problems together. So see how we're making the landmarks. And now, 2 years ago, there's been something interesting happening, the tipping point that led to ChatGPT, and that was the creation of creative AI or generative AI. To me, that started even sooner. It started in 2011 when IBM created a machine that was able to outsmart or win the game of Jeopardy, which is answering the questions in human language on time and mostly rightly. And so these two champions have been beaten by the computer in 2011, and that started the era of question answering systems that are on par with humans. So that was a breakthrough again, where we realized not only games, which are more like mathematical constructs, so okay, machines can do that, but language, which is one of the inventions, one of the key inventions of us humans, more than 2 million years. It's a way we communicate, we engage with each other, we pass knowledge. Now the computers can venture in that space and can work with us in that space. And then, to the surprise of even its authors in OpenAI, ChatGPT 3 came out, and when people tried it, they realized, hey, it can write songs, it can write poems, but it can even generate code, and in most of the cases the code is okay. The code is actually useful. It can translate from one language to another. So now we had a machine that was able to go from one to another, from one domain to another, which seemingly very easy sequence of steps. And that hasn't stopped. Then this generative, creative AI approaches were followed in the field of generating the art or generating the images. So you ask the machine, create me some kind of picture, and the machine was able to create that picture based on your prompting, your wording. So in case of there's a picture where you ask AI to create 2 teddy bears shopping for groceries in Japan, it would create it. If you ask it to do the same thing in ancient Egypt, again, it would create it based on the simple prompting that you provide to it. One thing you may realize is that if you look at those 2 teddy bears that are shopping for groceries in ancient Egypt, there's something that looks like a shopping window. Right? Shopping window probably not is not the concept from the ancient Egypt. So that may be an example of the AI network hallucinating, meaning creating something that isn't right for the given context of thing it's creating. We do that as human beings. We sometimes hallucinate as well, or we let our fantasies go further than expected. The AI is also subject to that concept of hallucination. So sometimes you need to be careful about what and how you interpret the results that are given to you by some of these systems. And then more and more companies have been providing these things. One thing to watch for is what are your data to train these systems? Where are the data are coming from? What's the governance of those data? Right? And Stable Diffusion, which is a program, has learned that in a hard way because the Getty Images, the major provider of the images for news and media, is suing this company because it turns out that if you ask it a proper way, the Stable Diffusion is able to generate images with Getty logo on it. Right? So the things has learned to generate images and hasn't learned to remove some of those logos or things that are not belonging to those images. So it actually revealed something that it shouldn't, the source of the data. Right? So it's very important to understand where the data are coming from, are the data legit, and be able to reference the data if needed. Okay, and we also do things in the voice domain. I don't have time to play you an example, but you can believe me that in the speech domain we also can simulate and emulate human voice very well, almost unrecognizable from the real ones. So that is happening all over the place. Text, voice, probably even video and other things. And then November 2022, many of you may remember it because that was the thing when ChatGPT has hit the roads, and it's been a fantastic success, I would say, in terms of how many people adopted that program and tried something with it. And then in March 2023, ChatGPT 4 came in, which even had images included in its reasoning capabilities or pseudo-reasoning capabilities. So if you ask ChatGPT what would happen if the strings were cut and you mean something on the picture, then it correctly answers the balloon would fly away. So it combines the textual and visual processing in a picture. So now if you go in deeper, a little bit deeper under the hood of what large language models, ChatGPT is a family of large language models, which are the things that we've trained or are textual artifacts. It's pretty simple. Its task is actually to do the following: take the sentence, and then each step predict the next word, and then base that next word and do the same thing again, and predict and predict and predict and predict. And it turns out that this statistical knowledge is enough for ChatGPT to generate very good answers to many of our questions, or even very good suggestions. It's not just the context of the sentence, It's also a context of the previous sentences and the context of something called priming, right, which is we supply to the neural network. And so it figures that how can I extend the sentence? This sentence could be the word can, could follow with probably 62% probability, the word will, 11% probability, and so on, so on. You may pick the first one. This is when the temperature is close to 0. But if you put something called temperature, which you let the neural network to actually play the dice a little bit and don't pick the most probable word, but pick something that is in the list. So it may pick R or capture, for example. Then you get a slightly different set of sentences and slightly different set of context. One important thing is to understand things you may hear if you use the large language models, the tokens. Tokens is concept similar to words, but it's actually are subword units, and for English, tokens are oftentimes connected directly to words, but for Czech, since the Czech vocabulary doesn't fit with the vocabulary of the large language models, then the tokens are something that is more subword units. So if I take the good afternoon, it's 2 tokens. If I take dobré odpoledne, it's probably 8 tokens in Czech language. The funny part that translates to money is you pay for each token. So by definition, if you're processing the Czech text, you actually pay much more than when you're processing the English text. Just a little bit on the adoption side. When we measure time for the first 100 million users for a given technology. So when Google Translate started, it took 78 months before 100 million people on the planet used that software. But you can look at the TikTok, it only took 9 months. For ChatGPT, it took just 2 months for 100 million people on the planet using the system, subscribing to the system. So the adoption rate is going crazy. Now, a little bit on the comparison of human brain versus those large language models. Because they really showed the astonishing linguistic capabilities. So why is it so, and what does that mean? So if you compare the learning process, we need to learn in our lives. We need to teach the networks to do things. Right? And turns out that we do it in a pretty similar way. There's a concept of reinforcement learning that we use in machine learning domain to create certain behavior or push for certain behavior. And the same concept of reinforcement learning, even though it's called conditioning in psychology, is related to how we human learn in a process. So if this baby wants to reach for a toy, maybe it doesn't reach it for the first time, it's handy short, so it knows it needs to do some action. That action would be, I need to move closer to the toy and then I can reach it. So it learns the chain together concepts to make sure it reaches the tasks. So we humans have one advantage. We have self-motivation. We do things with the goals. Or we have some external motivations. We get some reward externally. But the concept of the rewards, positive and negative, is something that we use when we're training those neural networks on a large scale, and you basically get positive and negative rewards to achieve the behavior that you need. Large language models, though, use more than that. They use unsupervised learning, where you just give them a bunch of text and tell them, learn from the text, typically by predicting the word that you hide for them. In the context, then they learn in a supervised way, especially the GPT-4, and then also learn through the reinforcement learning way. One major important between us and the large language models is that they doesn't have a concept of a goal, don't have a concept of some internal energy to achieve something, to do something, so they are not naturally curious. But on the learning side, there are something very similar. In terms of the my slide stopped. Can you move the slide manually, please? No? I probably said something that the large language models stopped the presentation and don't allow us to continue. So now I cannot move the slides backward or forward. But let me just talk back. So another thing you will see on the next slides is the way of bias or positioning. And it turns out that we, as we are small, we have a tendency to a certain age to prefer the gender of the same person. So we have some kind of a bias. And then under certain age, we do have preference to prefer person from our own communities. So that also represents a bias. And you will see in the picture then, the large language models, because they learn from the real data, they also have a bunch of biases they inherited from our own data sets. So if there's a sentence that says, the doctor was mad at the nurse because she was late, then in many cases, if you ask the large language models, the word she would really mean nurse as a person rather than she as a doctor. So there's a way that large language models learn from the data that when we say she, that the connection between she and nurse is much closer than the connection between she and doctor. And that's because that's been represented in the data. We do have techniques that does debiasing and that are able to actually remove the bias from the data. How we are doing back there? Still working on it. So another thing that is important is the amount of information that the neural networks learn compared to us. So question to you, if you are a college student, how many millions words you think you have seen in the process of learning? It's around 350 million words, right? Neural networks, when we teach them in the amount of tokens, those subword units, they already are in the order of trillions. So they see 1 million times more. We're able to run them through 1 million times more processes. So even though their brain is, I would say, 100 times smaller than our brain, then in terms of the amount of information, you get much more traffic, much more data traffic. So let's see if it moves on. No. Well, let me try this one. No. So I think we were probably stuck with this slide. Oh, now it's moving. Okay. So this was the thing I was referring to in terms of bias. So let me skip that part. And the doctor was mad at the nurse when she was late. Who is she referring to? The answer is she refers to the nurse. And if you circulate that meaning in the sentence at different times, in many cases she would be always referring to the nurse, right? Then another concept very important for how we deal with information, and we learn that during our age and even during the life, is the concept of attention, which is how to selectively filter from the incoming information through experience and time. So now in this room, there's a beautiful ceiling, but you don't pay attention to that ceiling, you pay attention to, hopefully, to the talk, but you try to filter information around us in a way we've learned to be able to achieve the goal. And on machines, especially in large language models, that was actually one of the key innovations that we have came up with, which is enable machines to learn from the input data to pick the only things that are relevant at that time. So all these large language models are based on something called transformers, which are concepts that are using attention to draw important things from the input data. So this is a thing from the machine translation. The sentence is, the animal didn't cross the street because it was too tired. And now the it thing, when it's going to translation step, when it tries to ponder what it is looking at several things in the input sentence. It's looking at the animal because that could be the animal. It's looking at the street because it could be the street. And it's looking at the end of the sentence because it's important with the context to the end of the sentence, right? So here, more of the weight is put on the word animal, so that would get probably translated as the thing it. Here in this context, the it is more focused on the street, so the street would be probably the one that gets translated over to the next one. Our decision-making and goal-oriented behavior based on attention is located in the prefrontal cortex. In machines, we don't know where that ability is located. We know roughly where it is, but we cannot locate it. There's no neuromorphism for machines yet. We don't have those brain scans of machines. So that's another important aspect. And then in terms of language acquisitions, I already talked about it, which is when we train the GPTs or GPT-4s, we train it on many tokens. 500 billion tokens, or GPT-4 even 13 trillion tokens. Wikipedia has just 3 billion tokens, so the thing we train it on is the whole internet, scientific articles, every book written on the planet, and with the images, you get even more images on the GPT-4 side. College student reads 350 million words, so you see that there's several orders of magnitude difference. And when we are young, we acquire typically 5 to 100 words monthly. So compare that to the speed, because we are able to train the GPT-4 in weeks, right? So that's something to compare. It turns out one thing we have very similar is that in terms of language prediction, the psychologists claim that we use something called predictive coding theory. So when I talk to you or you talk to me, based on what I'm saying to you, your brain is trying to predict what the next word would be that I would say, or what the next concept would be that I would say. That's exactly what the large language models have been trained to do. So that is very similar, and that's probably one of the underlying pieces for the good cognitive, or in their case, pseudo-cognitive behavior. Now, important disclaimer, it's been tested by some that ChatGPT provides up to 14% of hallucinations. So you may be careful in terms when you deal with that fact, but there are techniques how to avoid those hallucinations, how to minimize them. And one of the things I wanted to talk about a little bit is the planning. It's another thing that is related to intelligence, and again in the conference aisles you will see some of the planning algorithms that are used by the ChatGPT to do some things. So the ChatGPT is able to create a program, run the program, get the data from the program, and interpret it back to you. And again, that's a very important aspect of human brain, because human brain is based on planning, chaining logical steps to achieve a goal, including precondition effects and so on. We are getting into the ways where the ChatGPT will be running into limitations. One of those limitations is just the cost. So the cost of training GPT-3 is estimated to $5 billion, GPT-4, $100 million. Right? So training large language models, even bigger ones, is getting prohibitive because of the cost. And we don't see much of the GPU hardware coming in our way to help us to improve the training better. So that's one of the barriers. Another barrier, which is the right barrier as well, is a regulation. Right? European Union is putting together a EU Artificial Intelligence Act that actually is risk-based and divides the AI into 4 categories. And depending on the category, it gives you rules and regulations, what you need to do if you are putting out a product like that, like ChatGPT. We don't go into details, but just understand that there are things that are unacceptable risk. So in Europe, these systems that are based on social scoring are forbidden. We're not able to do social scoring in Europe. One thing that was added recently, because of the November 2022 thing, is there has been a regulation that is being put in place on generative AI, which will need to comply with transparency requirements. So every generative AI system, think about large language models, will need to provide its origin. So it says this text has been generated by AI or by a large language model. Avoid creating illegal content, and provide or prove that all the data that's been used for its training has a proper copyright. So that's something that will be in action soon. I think now it's being debated on the European level when this AI Act will be put in the action. So one thing at the end, now we're moving from the era of you or me as a person trying to get some information from internet or from a digital system. I typically work through a browser or any application, and that application goes to some digitized backend, and the digitized backend is giving me the information. And the digitized backend has been fed by computer programs. IT experts write computer programs to provide me this data, and subject matter experts provide the expertise that is digitized through the help of IT experts to put in this cloud. With those large language models in place, now that paradigm is changing significantly, because now you have, instead of a browser, you may talk to large language model, to this pseudo-cognition, and that pseudo-cognition not only gives you the access to the data, but may also work as an ID expert to some part. Remember the planning process, so it can create a code, run the code, get the results back and interpret it to you, but also can provide some information acting as a subject matter expert. So now through this box, you get access to all of these three things in a way that are comfortable to you, because it interacts, finds, aggregates, and executes information, know-how, and code happening right here, rather than you need to do it on your own side. That has advantages, that has disadvantages. Right? We may discuss that over lunch. And one thing to consider is, every time you do this change, and AI is a huge change in the society, there is something in psychology that is called Kubler-Ross acceptance curve, and when you are encountered with an event that is unexpected, then you typically go through a shock. You don't know what to do. Then you may go to a denial. It says, AI is not meant for me, I can survive it, I don't need to deal with it. Then if you discover that actually it's something that you need to deal with it, you may get even in frustration. I don't know what to do, I feel in the corner. You may get into depression. I'm really beaten down. I don't know what to do. And only then the sun starts rising for some of us, and we may start paying more attention in terms of how do we experiment with that, how do we use it to make better decisions, how do we actually integrate it in our mindsets. Right? So it's good to understand on this curve where you are, you as a person, and where your teams are in the company. Because I guarantee you that curve is happening. And we see it in the industry. So, one more minute? One more minute. So, what does the AI mean for you, for us? In management, managers will be interacting with humans in virtual teams. I'm joking that on HR side, the HR will be named human and virtual resources, because soon there will be virtual humans working with us and for us. IT, more of the code will be written by large language models or similar. Marketing, customer care, line of business, yes, there are many things to be used in AI to make things better. So basically there's a lot of building blocks that could be used to utilize that. We skip how to measure AI. It's a business as usual. You typically just run the standard business KPIs and operational KPIs. Just don't do AI for AI. Don't do AI just because someone tells you do AI. Just think about, can this be done by human? If yes, let's let a human do it. And the takeaways, this is actually from The Economist. So Economist says the transition has just begun, and that transition is conversational and language comprehension and superhuman powers of data assimilation and pattern recognition are there, and that leads to pseudo-cognitive systems that have strong implications on how we do things we do so far in our work, and also how we organize our lives. And it will have impact on the humanity. So, to put it simply, please do find your own terms with AI. You will need to do it anyway. I can tell you from my own personal experience, we are living that revolution together. Every week there's a bunch of new articles we're supposed to read about what's happening in AI, so it's really a thing. And the truth is, it's been around, the change is the only constant. So thank you very much for the attention.